Hello, good morning, good afternoon, good evening, whatever time it may be for you while you view our video here on Professor Pibot, a discrete math AI tutor. This is Mike Clopton speaking, ready to present you our slides, followed by the rest of my group 6 here in no particular order. So getting right into it, we have our project goals. And the objective here is to create an accessible AI-powered discrete math tutor that provides personalized learning support. So what does that really mean? That means discrete math is a difficult mathematics class that many university students struggle with. In fact, it's got one of the highest attrition rates in universities. So our sponsor approached us with the problem of solving this kind of issue, asking that, hey, can you use modern LLM capabilities in a functional web application to help students learn discrete mathematics? So we took that problem and broke it down into a few different ways. We chose or focused on 6 different keys that we thought would be best for helping us in solving this problem. So what we wanted to do, of course, is deliver immediate, accurate feedback on math problems. This is something that LLMs really struggle with now, and they're meant for more modern day creative writing versus solving distinct math. So on top of that, we also need to solve the problem of providing step-by-step guidance to help the students through these complex concepts. We couldn't just give them the answer, of course, right? Otherwise, they're not really learning anything. What's the point if you just have the answer? So now that the student has figured out the answer, they need to feel comfortable using the program, which leads to key 3, which is supporting multiple input methods for their mathematical expressions. We know discrete mathematics has many different ways to input an answer, and there's many different answers that are correct. So that was one of our important keys, was making sure that was a capability for students. Following that, we had to maintain high educational standards, basically preventing students from just blowing through these modules, getting the answers, and not actually getting any help. Which leads us into 5, which is creating an engaging, user-friendly experience. Of course, it's very important that it's user-friendly, otherwise no one's going to be using it. So that was something that we decided was the key. On top of that, students nowadays need something to track their progress. Otherwise, they don't feel accomplished. This is a modern teaching method, is helping them feel accomplished, that they've come from the beginning instead of just being where they're at now. They need to see some kind of progress going on. So that was something we identified as another key. So on our next slide here, we have project requirements and constraints, where we talk about on top of these keys, kind of broader from the specific keys, we have what the requirements are for this project. So that would be real-time interaction with the AI tutor. On top of that, you have secure user authentication and data storage. So that way each and every user is unique. It's not one specific user at a time. Following that, there's mathematical expression rendering. Like I mentioned before, you need to have multiple ways for these answers to come through, which is, you'll see later on in our slides. So moving on from there, there's kind of constraints on the other side. So we have these requirements, and now what's constraining us within these requirements are things like limited API calls to external services. Obviously, you have to have a limit to how often we call the services, which is why we developed a system like caching in our program. There's memory constraints for the drawing pad features. Again, we used a way that takes the input and scales it down, so that way we're not dealing with very high memory constraints, and you'll see that later as well. Response time requirements for AI interactions. A student's not going to use it if it's not quick and snappy, like other web applications, so we made sure to include that as well. So this is just some of the requirements and some of the constraints that we worked with, and the rest of my group members here will go through project design, implementation, testing, and finally Robbie will show you a really awesome demo of what we've accomplished, and I'm quite proud of it. So looking forward to you guys getting to see the what we would consider our finished product. So thank you.
Hello everyone, my name is Jared Spock. I will be going over the project design of our Professor Pibot. So the core features include an AI chatbot, which is powered by ChatGPT for solving the math problems, and also a chatbot to interact with and ask specific questions. We have a multi-input support with latex, photo uploads with MathPix, and a digital pen for input for tablet users. The curriculum was derived from Professor Yepes's homework, modularized in JSON files for flexibility, so we could always add more curriculum in the future. It has a secure user authentication with role-based dashboards for students. So you could upload pictures, you could go over your account, change the username, etc. Below is the ER diagram of exactly how our program works. It has a user interface, which then goes through the three inputs to the LLM, then the math validator LLM, and then everything gets uploaded to the database for the results. So for the front end, we use React and Tailwind CSS. Features include LaTeX editor for precise mathematical input, photo input processed by MathPix, and the digital pen for the input of the tablet users. Responsive design for ensuring mobile and tablet compatibility. The front end is hosted on Netlify for fast and secure access with HTTPS. And in the back end, we use Python and Flask. These features include a user authentication system for the students, communicates with ChatGPT powered AI to generate step-by-step solutions, and then it integrates with Supabase for storing user data, progress, and curriculum modules, tracking progress and managing feedback hosted on Render for scalability and reliability. Thank you.
Hello, my name is Gabriel Taveras and I will be discussing our project implementation. To start, our project is centered around an AI-powered chatbot, which leverages GPT-based technology, specifically GPT-4o, to deliver step-by-step solutions to questions. The goal here is to enhance students' understanding of challenging concepts by providing detailed explanations in an accessible way. By simulating a tutor-like experience, the chatbot helps bridge gaps in knowledge and fosters independent problem-solving skills. Next, we have our latex input and output. This feature ensures precision mathematical problems formulation and visually formatted solutions, making it particularly useful for students tackling complex math problems. In addition, the MathPix integration takes us a step further. It allows users to convert handwritten or image-based problems directly into LaTeX. Whether it's notes from a lecture or a snapshot of a problem, users can seamlessly solve and work on their tasks without needing to manually type equations. Together, these features make problem solving much more efficient. For user authentication, we had to ensure a personalized experience by implementing a robust user authentication system. This role-based system caters to both students and teachers, enabling features like progress tracking, profile management, and user-specific settings. Behind the scenes, we have integrated a very simple cloud-based database. It is powered by Supabase, which ensures secure, scalable, and affordable data management. This foundation supports a variety of features while maintaining the integrity and privacy of user data. We've also prioritized accessibility with a fully responsive, mobile-friendly design. Built with Tailwind CSS, our interface works seamlessly across all devices, including tablets like iPads and various phones. This all comes together when we deployed our project on the cloud. We used a front end on Netlify while the back end was on Render. This allowed for consistent performance and availability, as well as making it reliable, scalable, and easy to access.
Hi, my name is Esteban Rodriguez, and I'm going to be talking about project testing. So we use two different types of testing for our project. We use local application testing and LLM integration testing. For local application testing, this is typically so we can see the changes in the front end and the back end in real time. So what we would do is we would run the application, and we use Node.js because this is used for rapid testing and to increase development speeds. This is because, for instance, let's say we're developing the front end. If we make a change in the front end, instead of having to relaunch the entire app, all we have to do is save the file that we made the changes in. And what this actually does, it will do a hot refresh, and then now we just have to go back to our screen where we have the application open and all the new changes are there. Um, LLM integration testing, on the other hand, this was basically so we did run into a roadblock. It took some time to get the free, no, it took some time to get the paid GPT-4o model because the school had to provide it. So what we did instead, because we couldn't wait forever, or else we wouldn't have any logic for the tutor. So we use Grok, and that API gives us access to the Llama model, which is a pretty smart free model, and we were able to work our logic around that model since we're still able to query from there. Now, we're going to move on to this discussion. So we learned many key lessons during this project. And we learned that it's very important to have a thorough planning phase because it's really good to be on the same page for design and the system integrations to mitigate risks, from no misconfusion. And we learned that it's very important to have a very great user-oriented design. And we learned this from our sponsor as he gave us early feedback that we needed to have a more intuitive interface. And that really is true because once you see, like, let's say for a progress bar, you want to see an animation. You don't want to see static change, or else it's pretty boring. It won't grab your attention. And we learned this response AI behavior, uh, having like a fast response enhances the user experience. For instance, if it's taking too long to have a response, you might get bored and click off. And it's really important to prioritize the experience that the user has, or else they may not even want to use your tool. And we used GPT-4 because although it's a paid model, it is the best model to get the most correct answers. If we use Llama, we run the risk of giving our users incorrect answers, which is not the greatest. Thank you for viewing our project. Thank you for giving us your time, and now we're going to move on to the demo from Robbie.
Hi, I'm Robbie Salisbury, and I'm going over the demo video for Professor Pibot. So let's get started here. This is the home page, and we're going to hit Get Started to register. So just put whatever you'd like. So I'll do student at gmail.com, and whatever password you'd like. Register, that gets stored on the database. Now we can log in. So use whatever you made an account with. Logs you in, and then it takes you to your dashboard. This dashboard is able to store your information, pulling it from the database, and you can change it however you like. You have any progress, it shows you your progress, which we'll get to later into the video. So here, you can edit our info. So if you want to do like student 123 or change your email to anything, we can change that, update it, and now it's changed. And then here, you can actually create a profile picture that whatever you want, and it will store it over here. So now, let's go to the modules page. You can choose 3 different modules, whichever one you think is best. Today we'll do the demo module. So we have our first question: input the identity matrix of size 2 by 2 using the matrix input feature. But we're going to move on to a harder question to show you the features of the tutor. So we have this one right here. This seems a little more complicated. So say the student doesn't know the answer and they want to get like a hint or want to learn how to do it by themselves without getting the actual answer, you can hit hint and it sends it to the Pibot chat. And it gives you a bunch of hints until you run out. And then if you really don't know how to answer the question, then you can hit don't know. And it loads a detailed explanation on how to solve the problem, which should hopefully help the student learn. But unfortunately, everybody thinks differently, so this may not be a good enough explanation. So if you can also type in the chat directly explanation. Can you please give a simpler one? Puts that in the chat, and it's going to try to rewrite that explanation above to make it simpler. And you can keep playing with it until it personalizes your explanation so you can figure it out. So here we go right here, and we got a nice little explanation. Now let's see if it's correct. And it is. Now going back here, this is where we can show our input features. So you have 3 different options to choose from. You have the LaTeX input, which is this Math Pix keyboard, which is this Math View keyboard right here. And it's very simple. You have a whole option here for everything. But for a matrix, you have to click this and you can create whatever size you want. In this case, for an identity matrix, this is how it's formatted and it's correct. Now going back, you can also do a photo or a pen. So photo is like you wanted to write down the answer on a piece of paper. You know, you want to store it in that. You can take a picture of it, upload the photo here, and it will parse it as correct. That's the same thing. And going back one more time, we got the pen features. So most people use an iPad these days, and a lot of students is just that's their main thing besides a laptop. So you have this feature, very mobile friendly, where you can draw whatever you'd like. We'll be able to parse it using MathPix, and you get the LaTeX code in case you want to learn how to do the LaTeX yourself, or you have the parse LaTeX to show you the preview so you know exactly what you drew and what's being detected. And you submit that, and that's correct. Now, after answering this question, let's go back to the dashboard. And you go back to your dashboard, and as you can see your project progress down here because it's stored in the database. Whenever you get a question correctly, it takes that module and that part, how many questions there are, makes a percentage of how many questions you answered. In this case, we answered 2 questions, and now we have 20% completion in the module. And that's everything. Thank you.